6th graders. So today we're going to continue our discussion on volume of rectangular prisms, but we're going to talk about what if the cube size changes. So we're still in 6.G.A.2, okay, and it says how to calculate volume when the side of the cube is greater than 1. Now, a cube has the same unit as the length, the width, and the height. That's what makes it a cube, because it is a square that is made into a 3D object. And we know that squares have the same measurement on each of the sides. All sides are equal. So in a cube, all sides are equal. But if I have a cube where each of the sides is 1, then its volume is 1 times 1 times 1. And we know that 1 times 1 times 1 is just 1. So the volume of those cubes would be 1. However, if I increase the size from being 1 on each side to a greater amount, then I have to multiply that number by the length, the width, and the height to calculate the volume of each cube. Then the same thing is true if it's less than 1. If it's made into a proper fraction, I have to multiply that side by itself 3 times, okay? So I want you to think about this in a real life situation. If I have this container right here, and I use the same container all 3 times, and I have a regular size block, then it's going to take a certain amount. If I increase the size of the cube, it's going to take less to fill it up because the boxes are bigger. If I decrease the size, then it's going to take even more to fill up the same space. You see this? In this case, the unit would be, if it was 1 on each side, this is going to replicate a number greater than 1 on each side. And our smaller cubes are going to represent a number that has a fractional side, a cube that has a fractional side on each side, okay? So if you'll notice, the bigger blocks take up more space, so we're going to use less of them. The smaller blocks take up less space, so we're going to use more of them. In the same way as you could think about, back when we talked about what volume was, we talked about the tractor trailer that's transporting boxes. If we put smaller boxes in, we're going to be able to carry more boxes in that trailer. If we increase the size of the box and we put big boxes in, then we're only going to be able to load a smaller number of boxes in the same space. Well, that happens when we start our calculations. We're still using the formula volume equals length times width times height. So say we have a rectangular prism that has a length of 3, a width of 2, and a height of 4. Well, then our starting volume is all going to be length times width times height. But if you will look at our answers, they have changed. If I say that the side of each cube equals 1/2, I need 192 of those cubes to fill in the volume. Well, if it's equal to 1 on each side, then I just need 24 units because that's the volume when the unit is equal to 1 on every side. If I increase the amount to where each side of the cube equals 2, then look how much lower my number gets. Now I only need 3 of those. And that's because the smaller the cube, the more I'm going to need. The larger the cube, the less I'm going to need. See how much room this is going to take up versus 1 of these, okay? So in this example, it's like these 3 cubes being used. 1 is very small, so I need 192. 1 is the normal size, so I just need how many ever will fill up the box there in its size. And 1 is larger, so I'm going to need a smaller amount. So more for the smaller amount, I'm going to need a smaller amount of the larger one. Now let's talk about how to do this mathematically. Yeah, that makes sense in everyday life, but let's talk about how to do that mathematically. Well, you take your volume of your object, your rectangular prism, and you divide it by the volume of each cube. So, for example, in this scenario, it says, okay, where our length, width, and height are the same, so it should equal 24 units. However, each side of the cube equals 1/2. So I need to find what is the volume of the cube itself. So I'm going to take 1/2 times 1/2 times 1/2 because all the sides are equal because it's a cube and each side is 1/2. 1/2 times 1/2 times 1/2 equals 1/8. So the volume of each cube is 1/8. Well, now I take my volume as if it were equal to just 1, the cube was equal to 1, and I divide it by the volume of each cube, which is 1/8. Now we know that when we divide a fraction by a fraction, we use cube flip change because we're multiplying by the reciprocal. So I say 24 over 1 because I can divide 24 by 1 and keep it at that value. That's why we put it over 1. We multiply by the reciprocal, which is 8 over 1, and we get 192 units cubed. Remember, it's cubed because they're 3 dimensions. Now, if the cube is just equal to 1 on every side, then we get 1 times 1 times 1. Well, in that case, 1 times 1 times 1, that's just equal to 1. And any number divided by 1 is itself. And that's why it doesn't change when our side length of each of the cubes is 1. Because a number that's divided by 1 is that same number. Well, what if my cube gets bigger? In this case, my cube's getting bigger. So it says, what if each side of the cube equals 2? Well, now I have to calculate the volume of this cube. So I'm going to say 2 times 2 times 2. And when I say 2 times 2 times 2, I get 8. So I'm going to divide the original volume by 8 now, because each one of these cubes is taking up 8 spaces. So now I divide 24 divided by 8, and I get 3. So to break it down for you, anytime the question tells you that the unit is greater than 1, it's going to be worded like this. It's going to say something like, what is the volume of the figure if the side length of each cube equals whatever the amount is? So you'll calculate the original volume and you will divide it by the volume of the cube. And remember, each side of the cube is the same length, so they're only going to give you one side, okay? So you're going to say that side times itself 3 times. The length, the width, and the height. The length, the width, and the height of that cube. And then divide the volume by the volume of the cube to see how many cubes you need to fill up the space. And that's what volume is. Thanks for joining us.